Alright, today we're going to learn how to solve systems by elimination. So let's just say like we're not given a graph and we can't solve by graphing. We're not, and say that it gives us any two equations that aren't set in y equals or x equals, where substitution isn't going to be fairly easy. There is a process called elimination. So an elimination means that we can get rid of one of the variables. We can either get rid of x or we can get rid of y. Okay, so we do that by noticing that there are a negative version and a positive version of that variable of the same value. So this is a negative 1y and this is a positive 1y, so therefore they will cancel out. But in order to cancel them out, you are going to have to do the process of adding straight down. So 5 plus 3x will be 8x. These will cancel out because negative 1 plus 1 will be 0. And then 12 plus 4 is 16. And then you solve for that variable. So 8x equals 16. So 8 times what number equals 16? We'll divide. So x equals 2. Okay, so that means that the x coordinate of this system is 2. So in order to figure out what y is, you would plug x back into the equation. So I'm going to use this equation y because the y value is positive. Okay, so we have 3 times 2 now, because wherever there's an x, I can put a 2, plus y equals 4. So 3 times 2 is 6. And then you subtract 6 because we're going to solve for y. Y equals negative 2. So our ordered pair is 2, comma, 2, comma, negative 2. Sorry. All right. So that's how you would solve by elimination. So you got to try to understand like what would be the best situation possible. And then if there's not an equation that's in y equals or x equals, we wouldn't want to solve for that. That makes our steps that much longer. So what we would do is we would try to do it by elimination. So like this one. All right, so we have 6c plus 7d and then 6c minus 2d. Okay, so nothing can or eliminates right now, but I can make the 6's eliminate, okay, by turning one of them negative. Okay, and in order to turn it negative, I'd multiply by a negative 1, but I can't just multiply that 6 by a negative 1. I have to multiply the whole equation by a negative 1. So let's multiply this top one by a negative 1. Okay, so what I have now is a negative 6c minus 7d equals a positive 15. So what it does is it changes the sign of everything at that point. And then now I'm just going to rewrite my second equation. So 6c minus 2d equals 12. And then now I will multiply, or I would add straight down. So again, okay, negative c and a positive 6c would cancel those out. And I'm left with negative c, or negative 7d plus a negative 2d, which would be a negative 9d. D, not 90, but 9d. And then 15 plus 12 would get us a 27. And then we solve for d. So when we solve for d, we're going to divide by negative 9. And d equals negative 3. So now that I know what d is, I'm going to plug it back into the equation, any equation really. So I have 6c minus 2 times negative 3 now equals 12. And I'm solving for c. So 6c negative 2 times negative 3 will get us a positive 6. We'll subtract 6 from both sides. 6c equals 6. And then we'll divide by 6. C equals 1. Okay, so the ordered pair at which these two will intersect, the solution would be 1 comma negative 3. And I know to put C first because think of the alphabet. Okay, the C comes first in the alphabet. So, all right, and you can always check your answers by plugging C and D back into the equation and see if you get negative 15. So you would do 6 times 1 plus 7 times negative 3, and then you're going to see if you get negative 15. Okay. All right. 8m plus 12n equals 20, and then 5m plus 12n equals negative 1. So again, we don't have anything that eliminates right now, but because these n's have the same coefficient, we can easily turn that into a elimination process. So let's go ahead and multiply this by negative 1, so I can change that 12 to a negative 12. So then it's 8m plus 12n equals 20. And then our new equation is negative 5m minus 12n equals a positive 1. And then again, we're going to add straight down. So 8 plus a negative 5 would get us a 3m. These cancel out because one's positive, one's negative with the same coefficient. And then 20 plus 1 would be 21. And then we solve for our variable. So we're going to divide by 3. So m equals 7. So now that we know the value of m, we're going to plug it into the equation. So 8 times 7 plus 12n equals 20. So 8 times 7 is 56. Subtract 56 from both sides. I'm going to move this equation up here. So we have 12n equals negative 36. And then divide by 12. So n equals negative 3. And then again, you always put it in alphabetical order. So it's 7 comma negative 3. All right, last but not least. Okay, what variable would we be canceling out right now? All right, so you should say the y's because there's a negative 3y and a positive 3y. So automatically, these can go right into the elimination process because those will cancel out. 4 plus 2 is 6x. Negative 2 plus 26 will be a positive 24. And then we solve for x. So we're going to divide by 6. X equals 4. 24 divided by 6 equals 4. All right, now what do we do now that we know the value of x? Well, remember, anywhere there's an x, you can put that value. So we're going to do 2 times 4 plus 3y. Now again, it does not matter which equation you plug it back into, okay? Because they're going to work either way. It's a system. They work together. So 2 times 4 is 8. Subtract 8 from both sides. 3y equals, that'll be a 18. And then we're going to divide by 3. So y equals 6. So our solution is 4 comma 6. Because remember, a solution to a system is where the two lines will cross. So that's why you have to find the value of x and y. And I've told you time and time again that x and y always stand for an ordered pair. So what it's saying is, where do these two lines meet? Where do they share an ordered pair? All right. Bye, guys.